Hello, welcome to Code 2742, Tales from the Trenches. I'm Patrick Kremer, a staff cloud solution architect for VMware Cloud on AWS, and I'm here with my colleague, Steve.
Hi, I'm Steve Barron. I'm a senior solutions architect with VMware Cloud on AWS.
And we have an agenda here for you today. We're first going to talk about a Fling called SDDC Import Export, which is a Fling designed to be able to copy your network config, dump it out of an SDDC and be able to import it into another SDDC. And then we're going to walk you through converting a Cisco ASA configuration into VMC NSXT. So these are all techniques that we have used in the field to help customers get into VMC more quickly. So the use cases for SDDC import export for VMC, you can take your existing network config, you drop it into the JSON. It's all actually JSON on the back end anyway. And you can import it into a greenfield SDDC. There's a synchronization option, so you can actually synchronize objects across SDDCs. So think if you're running like a VDI farm, you've got 5 SDDCs for a VDI farm, and you want all the same firewall rules, and you can use it to synchronize. It supports compute and management gateway, DFW groups and firewall rules, network segments, the DHCP config. It'll do NAT and public IP remapping. It'll do VPN objects and service access. And there's also a feature to be able to synchronize service portal user roles from a template. PyVMC is a Fling that's a command line interface into the VMC API. It's an abstraction layer, so you don't have to know how to use the raw REST API. It's a CLI into the API. We're going to give you some practical examples on how to invoke the REST API so that you can do some automation in your SDDCs. Works on both greenfield and brownfield environments, and it has a bunch of CLI, a lot of the same operations that you can do in the import export you can do in PyVMC. So we're going to jump into a demo of SDDC import export. So there's a new HOL this year, HOL 228704. And you're actually going to see sort of a preview here of this HOL. So we're walking through what the SDDC import export Fling looks like. In order to do any of this work, work with any of the Flings, you have to know how to use an API token. So this is a shot on how you do it. Just here in the CSP, generate an API token. You got to give it a name. Now in this case, they're giving it all organization roles. It's best practice to limit the token to the bare minimum role. We're going to give VMC access and generate, and it creates this large string that you'd have to copy and paste. And then this is the code interface for SDDC import export. The main file that you have to paste things into is VMC ini. And there's really only 6 fields that you need to do the base import export. You've got a refresh token for source and destination. And you've got org and SDDC IDs for both source and destination. In this particular example, we're using the same org for both source and destination. So you can use the same token, but you can also use a completely different org. You just need a different token. So what we're showing here in the HOL is this is where you get the org ID and the SDDC ID. You just get them on the support tab. So we're going to copy them and paste them. I'm going to go through this kind of quickly. Save the file. And then this is our source SDDC, and the HOL just walks you through showing there's already network segments, there's already NATs, there's already firewall rules, both CGW and MGW. So it's a fully populated SDDC is basically what we're showing. And then we're actually going to run the export. So the Python file, import export py, -o is for operation, and you do an export. And you can see it dumping all of the rules out to JSON. It drops them in that JSON folder there. And then the HOL, then we go to the target SDDC, and we're doing the same thing, source and destination org ID. destination org and SDDC ID is what I meant to say. And we save it. And this is our target. And this is just, again, proving there's the default network segment. There's nothing else in this SDDC. It's completely empty. And then we run it in import mode here, import export -o import. And it gives you a warning and it says, hey, do you actually want to make a change? I'm actually going to write to an SDDC. Do you really want that? You say yes. It'll finish. And then you pop it open and your entire network config is done. So we've fully and completely imported and exported all of those network objects into a different SDDC. So pretty cool. That is one way to do it. You can import and export everything, but there are also a bunch of different config files. So if you look in the window, there's VMC ANI, there's a vCenter ANI, there's an AWS ANI, along with config ANI. So some of the more advanced stuff that you can do a selective sync. So all of those objects, the compute gateway, management gateway, network segments, you can turn them all on true and false. So let's say you just want to synchronize firewall rules. That's an option, right? You can turn them on and turn them off. Let's say you only want to synchronize VPN for some reason, you can do that. Other things you can do is you can do an on-prem DFW export. You can configure the Fling to point to an on-prem NSXT instance and dump your entire DFW configuration and then turn around and import it into the Fling, into an SDDC. You can archive network configurations into an S3 bucket. This is something that our folks that do a lot of live lab work for students like courseware. They will get an SDDC the way they want it, dump it out to a bucket, and then they can restore the network configuration for a lab scenario from that bucket. VCDR, there's a sample configuration for VCDR, and it's a way to speed up your recovery time objectives. So you can spin up an SDDC and get it the way you want it, and then export that network configuration, and then you destroy the SDDC so you're not paying for it. And then when a disaster comes, you spin up your SDDC and you can restore the network configuration. And it lets you knock that on-demand recovery time objective down because you don't have to manually configure all the network settings. For our customers that are migrating, a lot of customers have a very large multi-folder nested vCenter structure. And you can export your vCenter folder structure by configuring vCenter ANI and using the appropriate import and export commands. And the final thing that you can do that I'm going to highlight here is disabling VPN segments. So if you're working on this and playing and you've got a live SDDC, you don't want the VPN to accidentally come up in your test. So this will import your VPN configuration, but it'll disable it. So that's it for the walkthrough. I'm going to hand it off to Steve to talk about the Cisco ASA config side.
All right, thanks, Patrick. Would you mind stop sharing? Okay, so it became with some customer examples as they migrate from their on-premise environments into VMC. A lot of customers have legacy networking configurations, and migrating them into VMC is not trivial. Whether you have Palo Alto or Cisco ASA, one of the big differences, and typically between traditional firewall design and the NSXT is the distributed nature of NSXT and VMware Cloud on AWS. So traditionally, a firewall will sit as a kind of a hub and spoke model or at the edge of a customer network. That leads customers to have many VLANs, potentially a lot of interfaces. It creates a lot of issues, right, from a traffic flow perspective, because you have to aggregate all that traffic into a single device, which can bog down the device and create, the devices have to be built out to withstand that kind of traffic. With distributed firewall design, that's really not the case. NSXT is split out into compute gateways, a compute gateway management gateway, and then the distributed firewall. So we have to, as we're migrating from a legacy environment into the VMC environment, we have to be able to put the right segments where they need to go, and also put the right controls and the security policy and the new features within ASXT. And for an example, we built out an ASA environment with 5 or 6 VLANs, different security zones, different segments. As I went through and pulled the configuration out of it, you can see on the left hand side we have the ASA show command is what we're looking to pull out. The first thing I did was I built the interfaces. I took the interfaces from the ASA code and I built them in VMC. And so you can see the mapping here from the interface gigabit 0.1/100. We're going to name the interface and we're going to take the IP address. Now, a bit of a difference between the ASA config and the VMC config is we use CIDR notation. ASA config typically uses net mask notation, so that has to be converted. The desktop, or the desktop being the name, is really just a human readable environment. So as we go through and we'll take the 15 or 16 lines of code and we'll break it and put it into the script. The Python PyVMC script has a bunch of different commands to add and to show different network components, and they'll be called out throughout this presentation. Once we have the segments built, the next typical thing is to build network objects. In ASA code, a lot of organizations will have network objects predefined so they can be reused across their entire firewalls or within the firewall over and over again. So in this example, you can see on the bottom of the screen, the object group network monitoring services has both an entire network as well as a host configuration, and that has to be converted into the PyVMC command. The PyVMC command being new group, we're going to specify the type of group, and in this case, it's a compute gateway group. We name the group, and then we're going to add the members of the group. Now, there are different member group types, and in this case, these are all IP-based groups because the groups are based on networks or hosts. Another feature of the PyVMC client is the ability to add nested groups. So in this case, you can see within the ASA config, we have an object group called all-DB. That object group has subgroups called DB CRM and transaction and accounting. And we can actually incorporate nested groups into the PyVMC client. And you can see the big difference here is instead of it being an IP-based criteria, we're going to be using group-based criteria. Prerequisite, those groups will have to exist before you can use those groups as criteria for new groups. So, and throughout this kind of process I'm talking through, it is kind of a hierarchical setup. So some of these things have to come before the others, and they're called out in these slides. Another type of group is services. So services, and instead of being IP-based or group-based, services are going to be based on typically on source and destination protocols. So within the PyVMC client, there is a mechanism for new service. The service itself is a kind of a menu prompt-driven scenario versus just a field-driven. So when you go through this, you have to type new service. You put in the name of the service, and it's going to prompt you until you're done. When, again, you can see in this case, I'm adding 5 or 6 ports to a group, and then I had to type in the word done in order to get that done, and the results of that showing that the service group is created. Once we have the interfaces built and we have the network objects built and the service groups built, the next typical step is to take the access lists from the ASA and deploy them into VMC. And because we're running in a distributed firewall with the compute gateway and the distributed firewall service built into VMC, we have to actually split that configuration into 2 different mechanisms. So the compute gateway sits at the front of the SDDC and protects north-south traffic into and out of the SDDC to your workloads. Whereas the distributed firewall policies are intended to do that micro-segmentation within a VLAN or between VLANs within the same SDDC. You can see that this can get a little complicated, but you do have to go through and do an analysis on your ASA code to define whether or not the sources and or destinations are in the SDDC. So if the source or the destination is in VMC, then, but not both, then we can deploy that as a compute gateway rule. If both the source and the destination of the ASA config is, or the ASA ACL is in VMC, then we're going to have to use a distributed firewall policy. The other thing that I've run into as we were going through this with the customer is that they have a lot of groups, and sometimes were using groups, which was great, so we could go through and predefine those. But in some cases, they were just using IP addresses rather than groups. So then we had to go through and actually go back and redefine those IP addresses as groups within the NSX config. Once we determine the source and destination where they're going to reside, we need to make the decision if we're going to be using a compute gateway rule or a DFW rule. And then we need to go through and make sure those groups are built, and then we can deploy the rules. And this is, you can see that the distributed firewall specifically is kind of a nested configuration in itself, and that there are categories. So we need to understand what the categories mean. Typically, we're going to start at the infrastructure category, potentially the environment category, and ultimately, most often, the application category. The infrastructure category is typically going to be used for services like that you're going to allow or deny across your entire environment, like ICP or some of your network infrastructure or management infrastructure, things like that. Application is going to be very much more specific to an application. So we just need to kind of understand that as we're architecting our firewall rules. Once we determine the category we want to put things in, typically we're going to break things into sections just for human readability, and then we're going to deploy those rules to the sections. But you can see in this example, we have to define the groups. For instance, in this case, we're defining the middleware group as the source. We're defining the AllDB as the destination, and the services, MySQL and Microsoft SQL, are already predefined as predefined services. So that's not a big deal. But we do have to make sure we go through and define those groups ahead of time. So we can. Let's see. Okay, so within, this is where it gets a little complicated. I went through and parsed some of this stuff out using Excel, and then did some mappings to say at the bottom of this Excel file, and it might be hard to read, you'll see the access list and the name and how an access list is constructed. And then if we map those back, you can see about halfway through the list, we will put those into the DFW rule. So the PyVMC client has a command called new DFW rule. It requires us to have a name. It requires us to have a source and a destination and a service potentially. You can see that in some of these examples, we're using the any command or the any group. So you can see how that might be allowed. We have to define the action so we can allow, drop, or reject it. And then we have to define the section within the DFW we want to deploy it to. As an optional, optionally, you can add the sequence number, which I found really helpful to make sure that we're going through and ordering them in the preference in which we'd like them to be deployed. But if any of these prerequisites, if the sources or the destinations don't exist, or the services don't exist, we have to go back and actually build those groups before we go through and deploy the firewall rules. Compute gateway rules are similar, but a little bit more simple because there's not the concept of categories and sections. The compute gateway rule is much more of a top-down hierarchical structure. So we have the new CGW rule built into the PyVMC client. Again, it requires the source and destination groups to be defined, the services to be defined. Again, we're going to allow, drop, or reject it. One difference on the CGW rule is there are 4 different interfaces that we have to define if we want to, as the scope. So when it says all, that means all interfaces, obviously. Cross VPC is the interface that connects to the AWS native connected VPC. Public means internet. VPN is any VPN interface, and then direct connect is used for either direct connect with a private VIF or the VMware managed transit connect service. So again, we can sequence those and put those into the specific order. So that way we can go through and make sure that they're readable from our perspective. So as an example here, you can see that we're taking all the permit and deny, and we're dropping them into the right area. Same thing with source and destination and then the groups as well. And at the end, and I'm going to flip back over at this point. So at the end, we're taking the ASA config, which looks something like this, right? It's very kind of top-down architected, and it can be pretty cumbersome. I took that and we're doing kind of a transformation into the PyVMC client, and then doing a little bit of cleanup. And once we get it cleaned up, it looks more like this. So we can actually take the, let me jump over here. You can see that taking all of the commands out for the interface is going to leave me with this output. Same thing with the group members. I can go through and do IP-based or group-based, one thing at a time. But once I have these commands written, I can simply copy and paste those commands into the terminal, so that way it's actually going to go ahead and build out the interfaces, which it seems like it's a lot of work, I think, to get this ready to go. But as comparison to logging into the UI and doing this one click at a time through the process at scale, this is a much more effective way of taking your on-premise environment and modifying it, transforming it into VMC, and deploying it. And then at the end, once I'm done, I can show my networks. Just be show network. And I can see that my networks are built into here. You can see kind of here, they're kind of distributed throughout their. Same thing with the rest. I'm not going to go through and put all of these commands into VMC, but I have the command structure built out. And when we're showing this and it shows, I think there was a couple hundred ACL commands. It took me a couple hours to do, but I have customers that have, thousands or tens of thousands of ACLs to go through. And this is where I think we can really be more effective in getting these migrated over. Okay, and so the other thing at this point, we've got about 10 minutes left. I wanted to show another example from what my customers were dealing with. That we found that the PyVMC client itself was a really good documentation resource for the API. To be fair, I come from a non-developer background. APIs are fairly new to me. And when I started working with VMware Cloud and AWS, I was pointed to the Developer Center and the API Explorer. The API Explorer is a great tool to kind of visualize the API and see what's out there. But at the same time, it can be cumbersome because you have to know kind of what you're looking for, right? You can kind of see just in there's several different APIs, and then within this VMware Cloud and AWS API, there's different sections and groups and stuff. So once we got our hands on the PyVMC client, I found it pretty easy to go through and start to decode what they're actually doing. And so we had a customer that wanted to be able to, they love the PyVMC client, but they found that it wasn't quite giving them the level of detail that they were looking for. And as an example, the show SDDC host command was written by a colleague of ours, and it shows what the cluster name is and this kind of non-human readable name and the ID, which is just a GUID. The challenge that we had with this command is that in no point is this name presented to the customer either in the VMC UI or the vCenter UI. So they asked us about, help us figure out where, in a stretch cluster design, they were looking to understand where the actual host resided, what the availability zone that they lived in, what the actual host name was, so they could take those variables out and put them into their monitoring application for whatever purpose they were looking for. And so what I was able to do, and again, coming from a fairly non-development background, I knew that I needed to start here with the show SDDC host command. But by looking at through the PyVMC client, I can search for it. And I can see that this show SDDC host command is going to call this function, get CDC hosts, right? And if I search for that, if I search get CDC hosts, I can see that it's pulling, that I can actually start here. This is really important. It starts with the string URL. It dives into the API, the VMC API, and then it has a org. It has a variable for the tenant ID, which is our organization ID, /SDDCs, and then the SDDC command. I can map that directly back to here by looking through the API categories, VMware Cloud on AWS, general, SDDC. This is the actual command is running as org/SDDC, and then the SDDC variable. And I can go ahead and I can actually execute it directly from here as well. So I don't have to use the PyVMC client, but this is going to give me this JSON export, which if you kind of keep digging, this is where I got into just kind of digging with my customer to find out what exactly where some of this information is coming from. And I can dive into the AWS SDDC config and then the cluster itself. And then I can actually dive into the ESX host info. And ultimately here at the AWS ESX host info. And once I get down to here, I can see that there are some variables for ESXi ID, which is just this GUID that we present, and the ESXi state and host name. And this is what I really was looking for, was the host name, because this is what's represented in the vCenter client my customer was looking for. They also were really interested in this command, in this variable here, to understand, as they reported these host names back, they wanted to see the availability zone as well. So Patrick put me in, kind of gave me some other ways of doing this, because there's more than one ways to skin this cat, that we can actually just look at the JSON response as well. Because again, this result doesn't actually export any of the IP address information or availability zone or anything like that. But what I could have done is I could have just printed this JSON. Let's go back. If I wanted to, I could just print this JSON. And it would give me all of this information. You can kind of, if I scroll through it, you can kind of see that all of what I just showed on the API Explorer can be presented back to me through text as well, which can be kind of complicated as well. But if I can grab this, right? I want to grab into host. I can actually just pull the variables that have the word host in it. So there's that same host name, right? Same thing with availability zone. But what I was able to do, because now I knew that I needed to search for I wanted the availability zone variable and host name variable, because I was actually able to modify the table. Go ahead and hide that one. And the table and also the variables that are going to fill the table, right? So let me go ahead and do that. All right. Let's go ahead and rerun this one more time. Now I can see the same kind of pertinent information, that the first four columns are the same, but I just added the availability zone and the host name to this table, which was super useful for my customers. It took them about 15 minutes of perusing through the VMC Python client to map all of this back. And this is just kind of the tip of the iceberg, because we have dozens of commands built into the PyVMC client that all are calling APIs, and we're showing you a subset of what might be relevant, we think is relevant, but we're finding our customers have different opinions on what's relevant. So all right, and that is what I have. So I'm going to flip back over to remind you to, if you found this useful, please take our survey on the VMworld site. It does help us prioritize these kind of projects that Patrick and I are working on, and to make sure that we present more relevant code, more relevant content to you. So that's all I have. Thank you.
Thanks, everybody. Bye-bye.